Today we have judges that come from all over the community. We have them come from WIP, Devon Energy, the fire department. I'm trying to think of all the many places. There's so many. The mines, the different mines. I think we even had veteran services. What they do is the judges go through, and there's about 900 boards that they view. And they have a process. They use the same judging process that they use at regional and state level. And they grade the boards first, and then they pick, say, their top 4 or 6 boards, and they call those students in and interview those students, and out of those students they'll pick the top 2.
Are there different categories, or is everybody pretty much in the same?
There are different categories. They pick winners for plant sciences, cellular and molecular biology, physics, chemistry, engineering, environmental, and there's more. I just have to.
And 6th, 7th, and 8th all together, or separate?
No, we pick winners for 6th grade, then winners for 7th grade, winners for 8th grade, because there's a distinction, from beginning.
Sure. How long have they been working on these projects?
We start teaching the scientific method and working on them in August to have them finished by October.
Okay, my name is Bill Kingston, and we're here for the annual PR Leyva Science Fair. Every year we have a science fair, and all our students are required to submit a project for our science fair. As you can see, we have a large number of projects here, and we judge each and every one of them to see which ones are worthy of our prizes and move on to the next level of science fair.
And what's the next level?
The next level is our regional for our state. So they will be going to, I believe, Socorro or Portales, I forget which one is first, to show and compete with other students from around the state. First, it will be from the southeastern portion of the state, and then it'll be for the entire state. All the students have their projects summarized on a board. They're to show a hypothesis for their project, which is what they're intending to test or prove. Then they go through an experiment. They document the experiment. They also do research about their project and find literature that relates to their project to see what other people have done on a similar project and the results. Then they have to document their results. They show data in terms of charts and graphs, and all this is taken into account by the judges. So it's not just the appearance of the board, but it's all the information behind it.
Well, I know a lot of things have changed in the world since, say, I was a kid and did science fair projects. What's changed and what stayed the same as far as how science fairs go?
Well, I think what's changed is the type of projects. So maybe in the past there were a lot of things that were bugs or insect oriented, maybe things like that. Now we find projects like, can you charge a cell phone with a watermelon? So there's a lot of different technology now, and I would say that's the focus. But we also have a lot more engineering projects. We have a lot of projects where students have built either robots or parts of robots to make them work, bridges, different types of construction to see which is the strongest, which will last the longest.
Grayson McMinn, I'm in the 7th grade.
Okay, and what are we doing here today?
My science board.
Okay, what was your experiment?
Well, which type of bridge would hold the most weight in the model version?
Okay, and how did you decide to do that?
Well, I don't know. I just like building stuff, and I like I just put it together.
Well, tell me what your experiment was.
It was which type of bridge would hold the most weight basic beam bridge or suspension bridge.
Well, what did you do to test that?
Alright, I took this right here, you see? And there's a different type without the line right here. And the first test, it didn't hold a lot. I mean, it buckled at about 500 grams. And then when I put the line on there, it started slowly to buckle about 850 grams.
Okay, so the line supported it.
Yeah, but these sides were duct tape. These right here,
Yeah.
so it wouldn't just cave in.
So what was your conclusion?
My conclusion was that my hypothesis was correct, that the suspension bridge would hold the most weight, and that also that this would be the strongest part right here, this part.
Show me again. Oh,
This line, the
okay.
ends right here, and this is the weakest.
Okay, well tell me who you are
I'm Celia Fletcher.
and what grade are you in?
I'm in 6th grade.
Okay, and what's your experiment?
Mine's how well do horses learn.
Okay, and tell me what you did to test that.
I put some sweet feed and a carrot in one of the buckets, and I rotated it. I rotated every trial and see if they went to the bucket with the food the most, or if they went to the wrong bucket.
Okay, and what was the conclusion?
Well, I had a mare and a gelding who did it, and the gelding went to the circle more times than he went to the other buckets, but the mare, she went to the square more.
So what does that mean?
Well, on each bucket I put a symbol on it, like a circle, square, triangle, and the treat always went in the circle.
Yeah. Did they figure it out then?
The gelding did, the mare she didn't really figure it out.
Okay, well what inspired you to do this experiment?
Well, I like to event on my horses, so I was wondering how well they can learn, because maybe they can learn the course or learn the test or whatever I'm doing.
Mackenzie Berry.
Okay, and tell me what's your experiment?
It's about tornadoes.
Okay, what did you do?
I got 4 bottles, and you get two of them and you pour soap and water into one of them, and then I put a dark dye food coloring into one of them, taped the other bottle to it, and then I did the exact same to the other one, but I didn't use soap, and I used a lighter food coloring, and I taped them up and I flipped it and shaked them, and it was hard for the dark blue because you couldn't really see it, and the soap was clogging up the hole of it, and then the light yellow one, it was a lot easier to see, and I didn't use soap, so it was really easier to see.
Okay, well why did you pick tornadoes to do your experiment about?
Because I like nature and weather.
Hi, I'm Raimundo Juarez. I'm 14. I'm in 8th grade. This is my project. I did a NXT claw striker. Some of you may know what it is. Well, NXT is like Legos, but as you see the picture here, it's like robotics basically. And this is what I did was a claw striker. It's this is a not ultrasonic. It might be an ultrasonic sensor, but I can't remember what it was called. But it is some sort of sensor, and it detects objects, and depending on how far away from it is or how close it is to the object, it will back up or scoot forward. So in this claw striker, it will activate it through gears down here. The claw will move forward and retract itself.
Okay, and what was your experiment, your conclusion?
Well, my conclusion is right here. Said after I researched and investigated my project, I found out that they would need a lot of adjustments and tuning for them to be war machines, at least at this point in the design and programming. And what I tested was on the first one was a Elmer's rubber cement bottle, which was in all the information right here. But see, I think I would have got better results because I did on different objects. Like the first one was the rubber cement bottle, the second one was a salt shaker, the third one was a cup, and the fourth one was a pencil box. I think I would have got better results if I just did like different sized cups, the same object with different variables. but instead I did it with other different sized objects, different objects of all sorts and such.
Okay, my name is Simon Armijo, and my project was behavioral response to the visual spectral sensitivity of the Pteronoculus murnus, that is a tarantula species. And what I was trying to figure out is what if different light spectrums would affect their behavior, because it has been proven they are blind to red light. So I wanted to know if different lights will, if they're blind to it, how they would affect. So I'm going to be doing this for 5 years. So far I haven't got exact correct results, but over my observations, since they're still spiderlings, they are still burrowing because they have to, they are still young, so they know they're still prey. So I knew that that's still going to be same, but they're the same and different at the same point. So when I did this, I knew I wouldn't have results yet, but they are different, and it might be affecting their growth rate because the blue and green lights they don't have as much molts as yet as the rest of the lights. So when I did that, it's too early to tell for sure about that.
Well, you said doing over 5 years. That mean when you're next year as a freshman in high school?
Next year and through high school and possibly through college.
Okay, so you're going to keep working at it.
Yes.
My name is Ashley Stevens. My project is simple circuit logic with switches. It's an electric puzzle that I built. Here's the circuit that we built. My question for my project was who would be able to solve the circuit faster, females or males. When we were building the circuit, we actually came across many issues with building. What the circuit was supposed to do was, I have it here, but it was supposed to have a light bulb, and there's a question that goes with the circuit. It's a riddle. If you solve it incorrect, or if you do it incorrectly, the light bulb lights up indicating a wrong answer. But if the light bulb doesn't light up, then it means you've done it correctly. But we were trying to see who would be able to solve it faster. We couldn't get the circuit to work, actually. We went and talked to different people to see if they could fix it, but we didn't. We didn't manage to get it to work properly.
Well, since your experiment didn't work, but it sounds like you were still scientific about it, so the teachers were okay with the fact that you approached it correctly? Is that?
When we couldn't get it to work correctly, we went and we researched. We made up for what we couldn't do with research, and come to find out, females would actually be able to solve the the circuit faster, because they use both sides of their brain, whereas males only use their left side of their brain.
A lot of the projects are very good projects. When you go down and look at the different boards, you'll notice that the better projects have greater amount of data. They have more of an application. How is this used in the real world, and why is this important?
I thought it was interesting. One young lady, her experiment didn't work, but she had a really good kind of explanation and detail about why it didn't work. And so is that something that can happen where they...
We promote that. Anytime that you do a scientific investigation, what you think might happen might not, and that's part of scientific investigation. As long as they're giving it a good effort and trying, even if they don't work, their project has not failed.
Well, what happens tonight now?
Tonight, we're opening our science fair to all our families and the public here at Carlsbad, so they can view all the work by our students. They'll see all the ones that have been picked for prizes. They'll also see other ones. Also, as teachers, we'll be going through and we'll be selecting some of our favorites. Sometimes the judges overlook some projects that we know a lot of work was done for, and we want to be able to recognize those students.